of equations. And as we are writing those systems, a lot of these equations you've probably already seen before. So the key thing with doing both substitution and elimination and graphing is that we wanted to get to the point where you can solve real-world problems using one of those three methods. So if we look at this, we want to look at this problem and we want to try and write an equation. So when we are writing our equations, as we look at this one, we would want to start with looking at the number of right-handed students, if we are looking at that, in our math class is 9 times, if we're looking at that one, the number of left-handed. How can I write that equation? And you've seen this one before, and we probably want to use, instead of x and y, we now probably want to use information that goes with this problem, like the same variable. Total number of students in class is 30. If I was writing this, I might start that first one looking at the number, what this first statement is telling me. And the first statement tells me that my right-handed students is. Keywords in writing equations, is and was. Those often are our equal sign. Sometimes you might see the word of. Of usually means to multiply when you see that. Another thing when you're writing systems is a lot of times you might have one equation that deals with the number of something. So when you think of your two equations that you have, one is going to deal with the number of maybe tickets or the number of people or the number of something, okay? So the number that you have, and then the second one deals with the value, like how much it's worth, okay? So the dollar value. And so if you can kind of think when you're writing systems sometimes of these two equations, a lot of ours will be in standard form, okay? When we write an equation in standard form, that's like our ax plus by, okay, plus by equals c. But it doesn't have to be with x and y. We also will have some with slope-intercept. We usually don't have point slope. So if you're thinking of slope-intercept forms of equations, that's when you have something with y equals, and you have your rate of change. For m, that's your rate that you're changing, times x, plus b, which is your start. Okay? So those are going to be the two forms that when we write our equations that you're going to have. But from that first one in yellow, the number of right-handed students is equal, that's our equal, 9 times the left. It makes perfect sense to use R and L in our equations. Second one is dealing with the total number of students. Total number of students, that's my right-handed plus my left, is equal to 30. If you were looking at this one, Ryan, would you say substitution or elimination to solve?
Substitution.
I would go substitution too. And if you were substituting, tell me what I would write.
Well, then you it'd be 9L plus L equals.
I agree. 9L plus L equals 30. I have 10L equals 30. And my left-handed students happens to be 3. So how many left-handed students? There are 3 left-handed students. Now, pretty easy, and I don't even really need to probably show the work. But I'm replacing L with 3, and my right-handed students should be 27 right-handed. And when I look at that, does that make sense that the right plus the left equals 30? Yes, then it checks, okay? So looking at those equations as we do that. Joey, if you would read that next situation.
A plant nursery is growing a tree that is 3 feet tall and grows at an average rate of 1 foot per year. Another tree at the nursery is 4 feet tall and grows at an average rate of 0.5 feet per year.
What form should we be using? Slope-intercept, slope-intercept or standard for this one? What are they telling us? What do we want to be thinking about? There's some key words in there that would lead us to believe which form.
The average?
that average rate of change, the average rate that we're doing, which means we probably want to use slope intercept for this one, okay? So, we are trying to solve when will the trees be the same height. So, we want to have the height of tree 1, so H1, and what do we know? We know that tree 1 was 3 feet tall, plus it's growing 1 foot a year. Why? Because we're looking at year for our variable. The height of tree 2 is equal to, it started out at 4 feet, and it is adding 0.5 feet per year. Easiest way to solve this one if I'm looking at it, Brooke, substitution or elimination? Could do elimination, where we get rid of the heights. Is that how you would do it, or what were you thinking? I possibly, because the question says when are the 2 trees going to be the same height, I might have said, okay, I want to know when height 1 equals height 2, right? I want to know when they are the same. So you could have used elimination, and then you'd have to get the y's over on the other side. But in this case, you can also say 3 plus 1y equals 4 plus 0.5y. And substitution works quite well. Joey, right with us as you're doing, so we should have this all down in your paper. So as we are looking at that to finish solving, I would maybe subtract 0.5y, right? At the same time, could I subtract 3 to get rid of that number on that side so that I have 0.5y equals 1, and I'm dividing by a half on both sides. And so if I'm looking at my equation, I should have, they're going to be the same height in 2 years. So when I do that division, I get the 2 years. It doesn't ask what their height is, right? It just says in how many years. If they said, what is the height? Then you'd plug in 2 back here and you'd say, oh, they're 5 feet tall now. They didn't ask us that. They just asked how many years. So again, you don't necessarily have to solve for both variables when you're doing this, okay? Joey, you want to read that next one?
A local fitness center members pay a one-time $20 membership fee and then $3 for every aerobic class they attend. Non-members pay $5 for every aerobic class they attend.
We're going to write a system to model that, and the question we want to answer is for what are the number of aerobic classes? Will the cost be the same? So we're really trying to figure out their cost. So we might have the cost of our members and the cost of our non-members. The cost of the members is 20 plus each class we take 3 times A for an aerobics class. The cost for our non-members is they walk in the door, every class they take, they pay me $5. This one again, it says when is it the same? Now, you could use elimination, but you're just trying to find when the cost to the member equals the cost to the non-member. So 20 plus 3A equals 5A. Please solve that one right now. Do that now on your own. Track your A's. We're going to be looking at for what number of aerobics classes. So we want to find what is our A in this one. Samantha, what'd you end up with? A is equal to 10. Now, if you leave this answer just like this, and A equals 10, and you do that on our tests, okay? So on this quiz, it's mostly going to be you showing your work and solving it and giving your answers or pairs, or no solution or infinitely many. But if you do this on the test and you just leave A equals 10, I'm probably taking off a couple of points on the problem. Because the question said, what are the number of aerobics classes? So you would want to say, just like in English where you kind of restate the question, the cost is the same for members and non-members. So you impress your English teachers. You know, our science teacher, Mr. Olson, is really big on rewriting the sentences, so is Mr. Bradley. So the cost is the same for members and non-members when you take and you put 10 aerobics classes. So the difference of just simply telling me A equals 10 and then answering the question. So on the test, when we take this test, the key thing that I'll look for is, yes, mathematically, did you solve it using substitution or elimination? And on the test, I don't care which method you use. If you love elimination, you want to do that all the time, even though it's set up perfect, you can do that. But I'm going to look for, did you write out and answer the question? So you're going to get some worksheets in the next couple of days, and a lot of them are just these story problems that we're working on. Just make sure you're writing those sentences to finish. All right. Becca, you want to read first?
The school is planning a field trip for 142 people. The trip will use 6 drivers and 2 types of vehicles, buses and vans. Bus can seat 51 people and a van can seat.
So if we think, the first thing we want to look at is the type of vehicle we're taking. And you guys have seen this one, right? We got our bus, plus our van, and how many drivers did they tell us? 6 drivers. We can only have buses and vans, and we can only total 6. We only have 6 drivers, right? So the next one, after we look at the vehicles, is kind of like the value one. It's looking at the number of people. So Tanya, if we're looking at the number of people on each one, what might that equation look like?
1, 2, 4, 51, plus 10.
Yes. And I would have put the 142 last instead of first, like you said it, just because now it's set up perfect to do probably elimination, right? I want to know how many buses and vans. If I'm eliminating, I'm multiplying this whole first equation by negative 10. And I get negative 10b. I know when we did this one before, it was a substitution problem. This is set up just so perfect for elimination, right? We get 41b. The b's cancel. 142 minus 60. 82, it's working out really nice. Divided by 41, b equals 2. How many buses do we need? 2 buses. Oh, and once I get the 2 buses, how many vans? What would be the easiest equation to use? The first one. And we probably don't even have to write it out, right? How many vans do they need? 4. Why do I know 4? Because 2 plus 4 is 6. Kind of, you don't even have to rewrite the equation and solve it. If you want to, you could, but that first equation, you're just answering the questions, okay? When you start today's homework, the only part that I need done for Wednesday's class, because tomorrow we take the quiz, is you writing out the equations. I don't need you to solve all of them. If you want to start solving, that's great. But the key thing is you want to have the equations written correct. Okay? Devin, let's read these ones. Problem 5.
Measure of one acute angle
Keep going.
in a right triangle is 4 times the measure of the other acute angle.
Are you sick? Oh, man. So, Hannah, we know one is going to deal with the number of degrees in a right triangle. Okay? And we don't even really have to go with the total number of degrees in a triangle. But if I have a right triangle, right? I have this right angle. What do you want to call this angle? What variable? Because we don't know how many degrees it is.
X,
X, okay? And this one?
Y,
Y. And what do you know about X and Y in that right triangle? What do you know total number of degrees in a triangle?
90,
So X plus Y equals 90 or 90 in a triangle? Which one? Which question are you answering for me? How many total degrees in a triangle? No.
Oh, 1, 2. I'm
Yeah.
so
In any triangle, the total number of degrees is always going to be 180. All the degrees in the triangle, 180. This x plus y, yes, is going to equal 90 because this 90 is already taken off of the 180. Okay? All right, so Marie, she said x and y. Now we want to go back to this statement up here. And how can I write that equation? One is 4 times the other. What do you want to start with? 4x equals y. Could you have written y equals 4x? Yes. Could you have had x equal 4y? Would it matter? They don't tell us which one's bigger, so it doesn't matter which way you write it. Since she gave us y equals, this one is set up perfectly for substitutions. It's what are the measures of the 3 angles, okay? So, please solve this one. We would go with x, right, plus 4x equals 90. Perfect again for substitution. So even if some of you are against substitution and you prefer elimination all the time, some of these are just set up so perfect to use substitution. So we're finding x, and out of what you get for x? 18. So we're going to go back and answer the question. What are the measures of 3 angles in our right triangle? Well, one of them was 90. People often forget that one. We now have 18. And if the other two total to 90, we could take 90 minus 18, or we could take 4 times 18, right? Either way is going to work. So we should have, either way, 72, right? It doesn't matter if you take 4 times 18 to find y, or if you say 18 plus y equals 90. It doesn't matter which equation you use, okay? Last one that we are going to look at before we get started. Anyone want to volunteer to read? Go ahead.
The theater club sells a total of 101 tickets to its first play. A student ticket costs $1 and an adult ticket costs $2.50. Total ticket sales are $154.
We have seen this one before. Please try and write in standard form. That's the easiest way to do these, okay? Standard form is how these are set up. The first one deals with the number of tickets. So when you give me the first one, I want to know the number of tickets. So please try to write that. The number of tickets. The second equation is the value. Okay? Write it. Check with your shoulder.
101 equals x plus y for the first equation, and then 164 equals 2.5 y plus x.
So adult plus student equals, she used x and y. I'm using a and adult and student. My adult one was $2.50 my student was $1, so 1s, and my cost was $1.64. I don't care if you use x and y, but if you use x and y, then you really got to say x stands for student and y stands for adult, right? Whereas if I use a, I know a stands for adult, and I know s stands for student. So when you finish the problem, you got to make sure you know which one is your adult ticket. Is that your x, or was it y? Same with students, if you use x or y. So in this case, this is set up as a perfect to-do elimination. We can eliminate the students by multiplying this whole equation by a -1. And if I do that and I add them together as they are written, I'm going to have 1a minus 2, a -1a plus 2.5. If I'm looking at that equation, I have 1.5 adult tickets is equal to 63. And it's pretty easy to just solve by dividing both sides by 1.5 on my calculator. So if I'm looking at the number of adult tickets that we are selling, we should have in this case did you guys get it? Adults are 42. Versus if you used X or Y, so how many adult tickets were sold? 42 adults. How many student tickets? Has to total 101, right? So I could go 42 plus my adult has to equal 101. Track 42, the student ticket should be, yes, 59. So when you do your homework that we're going to be starting with, you're going to get 2 different sheets today. This one says 4C, and this one is due on Wednesday. And what I really want you to look at right now on this worksheet is the back page. And then this one, you should be able to do the whole worksheet and kind of write the equations, do all parts of it. So please turn it and look at the back, number 4. So the front, you're going to be writing those equations and doing that. But if you look at the back at number 4, okay, this is the bonus question. When we solved the system with 2 equations, when we graphed, our lines either had one solution, right? That solution was an x, y, or it had no solution tomorrow on your quiz when you take it. They didn't intersect, right? They had 0 equaled 5 when we solved it. Or you had infinitely many solutions. These have been our 3 options when we have 2 linear equations, right? So tomorrow's quiz, you're either going to leave the answer as x, y. You're going to tell me it's no solution or infinitely many when you do all the ones tomorrow, okay? You got to use the method they solve. This question tells you to use substitution to get the bonus points, and they give you your 2 equations. How many answers? So it says the equation for the circle is this. Now we haven't had many equations for circles. You get into equations for circle next year in geometry. You do a lot of it towards the end of the year of geometry. You do a ton of circles. You do their arcs. You do their all kinds of stuff with circles, okay? You do sectors. You do all kinds of different things. But at this point, we're just looking at this circle, and it intersects the line. In how many points? How many points does it intersect it? 2. How many solutions should we have then? We should have 2 solutions. Now, you should be able to tell me the solution right now to both of these without doing the substitution, right? So on the back, we're on number 4 on the back.
Yeah.
Please write the 2 solutions. Okay, you still don't get the bonus points yet. You're just counting over and up and telling me that ordered pair. In order to get the bonus, you have to show me using substitution, okay? When is this due? Well, tomorrow you have your quiz, so it's not due tomorrow when you come in, but it is due on Wednesday, okay? This next sheet that I'm giving you is what I want you to start on today in class. So this one is 27 questions long of story problems, and I do not want you today to solve any of them. I want you to simply start off with writing the equations. And once you have your equations written, I will give you an answer key that shows you all of those equations so that you can check it before you start solving it. Because it does you no good to go through and solve a problem and you have the wrong equations, okay? So, right now on this worksheet, what I want you to do is I want you to look at number 1. Try and just write and check with your shoulder partner the first page, 1 through 5, and then go back to number 24 if you finish that. We are going to do these together in a few minutes. Like we'll go through these.